Here is our third and final project for MSE 2001 over polymer slimes. This is just our table of contents. In order to create our slime, we used 1/4 of a cup of water, 1/2 of a cup of glue, and a pinch of borax. We first added the borax to the water and then stirred until we couldn't see any more powder in the liquid. We then added the glue, and to make sure it was fully incorporated, we took the slime out of the cup and played with it between our hands, which you can see pictured on the right here. We tested the slime in various ways, and we found that when you pulled it apart very quickly, it deformed almost instantly. However, when you pulled it apart slowly, it could stretch and stretch until it reached failure. Pictured on the right is another test in which we held the slime in one hand and slowly let it droop down due to gravity. Because slime is a viscoelastic material, we can assume that this is due to creep, or when a material slowly deforms over time due to a constant force. We also pulled the slime apart and held it at a fixed distance, which showed us that the force required to keep it stretched decreases. This is due to stress relaxation. The amount of recoil that the slime needs to get back to its original length decreases. To create our bouncy ball, though the mixing stage stayed the same, the recipe changed slightly. Instead of the ratios we used prior, we used 1/4 cup of water, 1/4 cup of glue, and 2 pinches of borax. In other words, we increased the amount of borax we used and decreased the amount of glue we used. This new ratio made a thicker and firmer slime, likely because the extra borax created more cross-links. We also performed several tests on our bouncy ball, and while we found that it behaves mostly the same as slime, we also found that more force is required to achieve the same deformation, and it only deforms slightly with time in response to gravity. This test involving gravity is pictured on the right. We also performed a drop test in which dropping our ball from a height of 7 inches made it bounce back up 3.5 inches. As previously mentioned, the differences between these two slimes is the fact that we added more borax to the bouncy ball, which means that, in turn, the bouncy ball has more crosslinks. Take, for example, the comparison test that's pictured at the bottom of the slide. After rolling each of these slimes into a ball, setting them next to each other, and waiting a small amount of time, we found that the slime relaxed to the shape of the table and lost any overhangs, while the bouncy ball showed minimal changes and relatively kept its shape. Due to these observations, we can assume that the slime has a smaller Deborah number than the bouncy ball, because in the same amount of time it relaxed more than the bouncy ball. Thus, the bouncy ball, with more crosslinks, has a higher Deborah number.